Hello.
Good evening, sir.
Yeah, good evening. So there was a third problem that I wanted to discuss yesterday.
Yes.
The question says let A is less than equal to B, less than equal to C, be real numbers, and you have A plus B plus C is equal to 0, and A square plus B square plus C square is equal to 1. You have to prove that B square is less than equal to 1 by 6. So there is a reason we are trying to do this problem in the chapter on quadratic equations. So you have to think right now there is no reason why it should be a quadratic equations problem.
Yes, sir. So we can take C as minus A plus B, and then we can put it in the equation. Then we
But
get
you
uh,
should not put C as minus A plus B. You should isolate B because you
oh,
have to prove things about B, right?
yes, sir.
So don't try to convert C into minus A plus B. That won't help.
So what I was thinking was it would eliminate C, and then we would get a quadratic equation in A and B. Then we would use the discriminant condition to eliminate A, and we would get range of B.
So have you tried it?
Yes, sir.
क्या हो रहा है इससे?
सर ऐसे तो इक्वेशन आ रहा है पहले 2a² + 2ab + 2b² - 1 = 0.
2A square plus
2ab
plus
2b² -1.
okay. This equation is coming. We have to prove B
Quadratic.
square is less than 1 by 6.
Yes, sir.
So
So
you
we
can
can
think of it as a quadratic in A.
write
तो उससे कुछ हो रहा है.
d पॉजिटिव करने पे हो जाना चाहिए. I
So
think we are getting a kind of subset here.
we are getting minus 16, so minus 12 B square plus 8. So you're getting 12 B square is less than equal to 8. So the B square is less than equal to 2 by 3 are. But what we need is a sharper inequality.
Okay.
ये आ रहा है condition, but this is not sharp enough for us to prove, right?
Right.
So you have to think of something else because this is not enough,
Okay.
right?
So can we get ABC value here? Value of A into B into C?
How will you get that? I don't see any way.
If we could get it, then there's another way also. We could imagine a cubic equation with roots A, B, and C. Then the x square term would be 0, and then we would prove that one of the root is between -1 by root 6 to 1 by root 6. The way for proving would be like limit x tends to minus infinity would have a different sign. Uh,
No,
and the other,
if
yes,
you get a cubic equation, what are the roots of that equation?
A, B, C.
हाँ, so उससे नहीं होगा ना.
Yes.
ऐसे करोगे middle term A B B C C A you are saying is 0.
No, sir. A plus B plus C is 0. AB plus BC plus CA is -1/2.
Okay, and what about the next term
Uh,
ABC? तो ABC तो पता नहीं है ना.
ABC सर A³ + B³ + C³ के बराबर हो जाएगा.
हाँ, बट
वही
पता
चीज.
नहीं है ना वो सब.
हाँ वही प्रॉब्लम.
पता ही नहीं है कोई वैल्यू तो फिर कैसे करोगे?
हम्म.
You have A plus C is minus B, and then we have AC can be written as A plus C whole square. Just hold on for a second. Right, so A plus C can, AC can be written as half of A plus C whole square minus A square plus C square. And basically this becomes half of A plus C is minus B, so B square minus A square plus C square is 1 minus B square, right? Correct. So from here, what you will get is AC is equal to B square minus half.
Okay.
You are getting B square minus half, right?
Yes.
Now it is good because we know A plus C and we know AC. So we
Yes.
can make a quadratic, right?
Yes.
We can make a quadratic f of x is equal to x square minus of A plus C x plus AC, right?
Yes.
So this will be x square plus bx plus b square minus half.
Yes.
Correct?
Right.
This quadratic has roots a and c. So obviously its discriminant would be positive, but that will not give us the condition. That will be a condition that will be weaker than what we know,
Yes, sir.
what we need, because a similar thing you have already tried, right?
Yes, sir.
But what can we say here? Roots are a and c. We can say b lies between the roots. So f of b is less than 0, right?
Yes, sir.
To put f of b is less than 0, you get b square plus b square plus
Yes, sir.
b
Now we get
square.
less than less.
तो इससे प्रूव हो गया b square is less than 1/6.
Yes.
So what are we doing here? We are saying that, okay, a plus c and ac we can find using this.
Okay.
AC has come in terms of b, a plus c also in terms of b. So we get a quadratic only in terms of b with roots a and c.
Yes.
But we are not using the discriminant greater than 0 condition. We are using the fact that this part we had not yet used, right?
Yes, sir.
B lies between the roots, so f of b is less than 0.
Okay.
Correct?
Yes.
So that is the solution. Let's look at another problem. Here we have let u be a root of x square minus x plus 2 is equal to 0, and let m and n be positive integers such that u square plus 1 to the power m is equal to u square minus 1 to the power n. You have to prove that m is equal to Pn. Not very difficult, try it out.
Yes, sir. Sir, I think there's some
You
kind
don't
of
have to say anything.
okay.
Finish the problem correctly, then you have to say. What is the complex root you are getting for this?
1 plus minus I root 7 by 2.
By 2.
Yes.
So use this root to try to get from here.
Okay. So u plus I and u minus 1.
Don't try to square it, okay?
Yes, sir.
Why? Because you can use the fact that u square minus u plus 2 is 0. You can say u square plus 1 is equal to
U minus
u
1.
minus 1.
Okay.
And you can also say u square minus 1 is equal to what? U square minus 1 would be u minus 3.
Yes, sir.
Then you will not have to square the complex number.
Yes, sir.
Then you have to solve the equation to prove m is equal to 3n. Are you getting the proof?
No, sir.
क्या दिक्कत हो रहा है? अगर u we take as half plus, for now we are doing it for the positive u.
Okay.
What is u minus 1?
Minus half plus root 7 by 2. Okay.
U minus 3 would be minus 5 by 2.
2 plus.
From here we have to prove that m is equal to 3n. What can you do for this?
Uh, sir, sir, I don't think something. So the only thing I can think right now is of using binomial and equating real and imaginary. So
That's not the way to do it. That will be too long.
yes,
This is
sir,
a complex number.
not here.
This is equal to another complex number. The best way to do it is to convert each of, because you have to raise it to a power, convert it
Euler
to
form.
REI theta.
Yes, sir.
And then ultimately it doesn't even need fully Euler form, but the point is if you take mods on both sides, mods have to be equal.
Right.
Mod of this complex number is how much? 1 by 4 plus
Right.
49 by 4, so 50 by
2, 2.
4.
Yes, sir.
So that is 25 by 2. So 1 by 4 plus 7 by 4.
Yes, sir.
So 8 by
Root
4, so root 2. Root 2 power m should be equal to 25 by 4 plus 7 by 4. So
4.
32 by 4, so 8, no, 8 power n.
Yes, sir.
8 आ रहा है ना क्या आ रहा है?
8, 8. Okay.
So you are getting 2 power 3n is equal to 2 power m by 2. We have made a mistake somewhere.
Okay. 25 plus 7 is,
Check the mods.
yes, sir. 25 plus 7 by 4. So that should be 8 only.
So 2 power 3n and 2 power m by 2. M is coming as 6n then.
Yes.
Minus half plus 7.
7
Maybe there is a typing mistake in the problem only because m is coming as 6n for us.
Okay.
Right?
So it should be root 8.
Hmm.
So 3n by 2 we are getting.
So m is 3n then.
Okay.
So the main thing when you raise a complex number to a power, you have to do Euler form, and if they are equal, then obviously the mods will be equal.
Yes, sir.
So this should not be a difficult operation. This should be easily doable for you.
Yes, sir.
Binomial is not the way, never. You
Okay.
have to either convert into polar form cos theta sin theta or EI theta.
Okay.
It is never binomial. So very rarely you will have to do binomial here.
Okay.
Okay.
Hmm.
Next question is find all polynomials of degree 2 px is equal to alpha x square minus beta x plus delta, where alpha beta are its roots and delta is discriminant of px equals 0. Find all polynomials which satisfy this condition. The
Okay.
polynomial itself is made up of alpha, beta, delta, and alpha, beta are the roots and delta is the discriminant.
Okay.
क्या हो रहा है इसमें?
So, so the first thing is delta equals to 2 alpha minus beta whole square. Then alpha plus beta should be
You have not gotten
beta.
anything yet.
Yes, sir. I haven't got any. Beta by alpha it should be. This should be right. 2 alpha plus
Why are you not getting? This is not very difficult.
yes, sir.
These are the three equations you have.
Yes. So delta equals to beta square by 1 plus 4 alpha.
From here, delta is alpha square beta. You can put that in this.
Yes,
You
sir.
get alpha square beta is equal to beta square minus 4 alpha into alpha square beta. You get basically beta square minus 4 alpha cube beta is alpha square beta. Alpha beta cannot be 0 because
Yes.
alpha is 0, then this is gone.
Okay, so beta can be cancelled out.
If you cancel out beta, you will get, or
Yeah.
first you cancel alpha square.
So we don't have alpha square.
1 second. From here, if you cancel beta, you get alpha square is beta minus 4 alpha cube. And so basically you're getting beta is equal to 4 alpha cube plus alpha square. And now we'll use this in the first relation. You'll get alpha plus 4 alpha cube plus alpha square is equal to 4 alpha cube plus alpha square by alpha, which is 4 alpha square plus alpha.
Yes, sir.
तो इसमें मुश्किल क्या है? मुझे तो मुश्किल नहीं दिखता कुछ. It's
Yes, sir.
over.
3
तीन
alpha square.
तीन equations हैं and you have to solve.
Yes, sir.
Alpha is coming out to be 4 by 3.
Hmm. So beta can be also calculated.
Alpha is 3 by 4. Alpha is 3 by 4. Beta will come out to be 9 by 4. And
Okay.
delta will come out to be 81 by 64. This is not a difficult question. You need
Yes,
to
sir.
be able to solve it. You
Right.
cannot get confused with तीन equations में कैसे कोई confuse हो सकता है? One by one you have to eliminate variables.
Yes, sir. Right.
Delta यहाँ से लेके इसमें डाल के you have two equations with two unknowns. Then you have to eliminate beta or alpha.
Sir, the way I was finding delta was actually wrong. So that's why I got stuck.
What do you mean wrong?
So
Delta is discriminant. There is no other way.
I was doing alpha equal to beta plus minus root delta by 2.
What? Alpha is equal to?
Alpha equals to beta plus minus, sorry, alpha equals to beta plus root delta by 2.
Why are you using quadratic formula?
Yes, sir, that's what I did. So I got stuck, I think.
Quadratic formula, you don't know which one is alpha, which one is beta, how to put where
Yes, sir.
with the plus
Plus,
minus sign.
right.
Why are you not using basic Vieta's relations and discriminant? What is a discriminant?
So I used the first and second equation only, not the third one. For the third one, I made this mistake, I think.
Okay. Let A, B, C, D, and P belong to real such that PAC is equal to B plus D. P belongs to minus half to half. Prove that at least one of the equations x squared plus ax plus p equals 0 and x squared plus cx plus d equals 0 have real roots.
Okay. Sir,
Hmm.
sir, I think it's complete, right? So, we can take delta one as the discriminant of the first one, a square minus 4b. For delta two, it can be c square minus 4d. So we just add delta one and delta two.
Mhm.
Uh, then we get, yes, sir. Uh, so we take the minus sign common and we get 4 PAC. And so just for assumption, we can take delta one plus delta two as positive.
How can we assume that? We don't know.
Yes, sir. We assume that. So a square plus c square is greater than 4 PAC.
That is an assumption. How can we prove it by assuming?
Sir, because we don't get any kind of contradiction. So
That's not a proof. You have already assumed the thing that you need to prove.
yes, sir. So is that an error?
Obviously, how can you prove something by assuming that it is true?
No, sir. If we would get some kind of contradiction, then this won't be true. Like I was following this thing.
But if you don't have a contradiction, then it is true. Always.
Uh, so, no, sir, I don't think so.
मतलब कोई चीज प्रूव करना है उसमें उसको अस्यूम कर लेंगे और कॉन्ट्रडिक्शन अभी तक नहीं है तो मतलब हमेशा के लिए प्रूव हो गई।
Sure.
कॉन्ट्रडिक्शन हम लोग उल्टा असम्पशन लेके प्रूव करते हैं।
Okay. So, sir, we can do that way. We can consider it to be negative.
The point is you need to show that one of the two equations has real roots for which
Sir,
one of the discriminants should be positive somehow.
yes, sir. So, yes, sir, exactly.
If you can show that delta 1 plus delta 2, if it is greater than equal to 0, then both can't be negative.
Yes.
So ultimately,
Sir,
your job is to prove this is happening, not assume it is happening.
okay. So, sir, I think we can add and subtract 2AC and
Mhm.
delta 1 plus delta 2.
So
So we get a square plus a plus c whole square.
you should be taking a minus c whole square plus 2ac minus 4pac.
Uh, then we can take 4 PAC common. Uh,
You are getting something like this, but this is positive, but AC sign we don't know.
okay.
You
So, but
understand that AC ka sign pata nahi hai.
yes, sir.
So it is not guaranteed that the whole thing is positive, right?
Yes, yes, yes. Mm.
You have to prove that the whole thing is positive, but the proof cannot assume it is positive and we are not getting a contradiction. That's not a proof method.
Okay,
Do you understand the problem with that?
okay. So, would it be fine if we consider delta 1 plus delta 2 negative?
Then you have to show a contradiction.
Yes, sir. There I can plan a way to get.
Do
So,
it.
that will be a simple AFGM inequality right there.
How?
So could you write? Then I would show. A square plus C square less than 4AC. So we would divide. Acha, again, we don't know about the sign of AC, right? Sorry. Uh, if we would divide, so we are not sure about the sign of AC, so we can't do this, right?
Hmm. This expression we can write as a square minus 4pac plus 4a square c square plus c square minus 4a square c square.
Okay,
No, that is also wrong. We can do p square c square obviously plus 4p square c square plus c square minus 4p square c square. This makes the first term perfect square of a minus pc, 2pc.
and the second one has to be positive, right?
Second one is positive because of this.
Yes, sir.
So the whole thing is positive now.
So we have at least one as positive.
That is the proof. We have shown that delta 1 plus delta 2 is greater than 0 for sure.
Yes, sir.
It is by completing the square, but not in the standard way with 2ac.
Okay.
If you use 2ac, you cannot prove it.
Yes.
If you
So this
use this expression as middle term and p square c square, it will come.
this was a tricky manipulation actually. That's why
That is not the main problem. The main problem is if you think the proof is correct, if you assume it is true.
Okay.
That is a big issue.
Yes.
If you have to prove something, then you cannot assume it is true and have not gotten a contradiction.
Right.
If you use contradiction method, you have to assume the opposite
Okay.
and get a contradiction.
Yes.
Uh,
So in the way which I was telling that we can consider it negative, we could make cases like AC being positive at a time and once being negative.
can make cases and you can try to see if any contradiction is coming.
Yes, sir, because that time I remember it, I was getting two like greater than or so we have a relation like x plus 1 by x minimum value, I think like we do have something, it lies between minus infinity to minus 2 and 2 to infinity. Right, it gives values between those intervals. So in two cases we would get minus half and half for p.
That is only if both x and 1 by x are same sign. Both have to be positive, right?
So sir, a by c and c by a, I think would have same sign.
A by c and c by a is fine, but
Yes.
I'm not
So
sure if
that's
you're
a
getting
length.
that.
Okay.
You have to check it out. Maybe it is possible to get a proof by contradiction, but I don't know. The
Okay.
simpler proof is straightforward.
Yes.
You have to factorize this basically.
Okay.
Okay, these three questions are your homework.
Okay.
First question, think about a quadratic expression somehow. You can take any variable, right?
Yes, sir.
Think of it as a quadratic in one variable.
Okay.
If you think of it like that, then maybe you can factorize it. Otherwise, you can't. Anytime you have a quadratic, suppose like this, you can always write it as x minus alpha times x minus beta.
Right.
So if you have A, B, C and all, you can write it as a quadratic in A and B. You can write it as A minus whatever is the root of that quadratic times A minus another root, right?
Okay.
Do you understand what I'm saying?
Yes, yes.
So that is a way to factorize. If you don't have any other standard way here to factorize it, that is a proper way to factorize because you can think of it as a quadratic in either variable, any variable.
Yes, sir.
So try it out. Question number 3 is involving triangles, properties of triangles and quadratics. So you have to think about that carefully. It is a good
For the
question.
okay, so for the second one, I think we have a kind of Lagrange identity. We- A
You don't
square.
need any additional information. You can solve it without using any such thing. You don't
Okay.
need any identities for it. It's basic. Whatever you know, that much is enough.
Okay.
So try these three. We'll discuss it tomorrow.
Okay. Thank you.
Hmm.